Chapter 3, EcmaScript Modules. So people have been trying to figure out modules in JavaScript for a long time. EcmaScript modules, the official standard, were released with ES6 in 2015 and available in all major browsers by 2018. But there's still an unfortunate amount of division and confusion in the JavaScript community. To understand this, let's see how we got here. In our last chapter, we started separating our app into individual scripts, which were just loading into the page in the head tag of the index. But we saw that if we just put one thing in the wrong place, the entire thing breaks. And let's take a look at how this loads in. If I just hit refresh here, you'll see that each one is waiting on the last one. That's not the kind of waterfall that you want to see. We're loading every single thing in here. Home, about, products. We're only asking for the home page, but we have to wait for every single script tag to load in here before the actual thing works. And if we look at the window, which is the global object, we can see that all of our global variables are just sitting here waiting to be used. So while we wrote all of this ourselves and we kind of know what everything does and how to load it in, it's a problem if two libraries want to have the same name. It's pretty unlikely for something else to have something called about, but it'd be a shame if that library didn't work correctly or our view template didn't work correctly because they both had the same name and one canceled out the other. We'll see this more in a moment, but to understand how to fix these problems, we're going to have to travel through the history of JavaScript modules. The module pattern in JavaScript has traditionally been implemented with immediately invoked function expressions, also known as IIFEs. Coined by Ben Allman, he literally says it right here, IIFE, if you don't believe me, but I will be calling them IIFEs from now on. And so if you look at how you define an IIFE, you open a set of parentheses, you start defining your function, and inside you can put whatever variables and functions you want in here, and then you close the parentheses and run them. And you create what is known as a closure, which hides these variables and functions away from the global scope. So as we enter the module scope here, we create a variable, a string of cheese that is made out of cheddar. And then we even create another IIFE inside of our IIFE where we create a new string of cheese made of Gouda. We log that to the console, return the cheese, and then run the function. And then we log the cheese to the console again. But the only string of cheese it can find is the one that we defined at the top of the module scope here, which is cheddar. And then we return the cheese. So in index.html, what do you think we're going to find in the global scope? Well, when we created our IIFE, you will see that we have Gouda, which we made in our interior IIFE, logged that to the console and ran it, returned cheese, but we didn't assign anything to this IIFE. So when we create the closure, the cheese is gone. This is entirely done. We move on, and when we log this cheese, it's cheddar, and we return that, but there's nothing in the document because we didn't assign it to a variable. So if we want to expose this to the global scope, all we have to do is just assign it to a variable, and then you will see that the variable is cheddar in the global scope. And so what happens though when we bring in multiple other scripts that are also trying to affect the global scope? Like perhaps this one thinks that cheese should be mozzarella, or window.cheese should be brie. How do you think the global scope's going to look now? Well, when we load it in, it's just whatever the last script that we load in. So dependency management is still an issue. We still have to worry about the order in which we bring our scripts into the document, because now the cheese is mozzarella in the global scope when we look at the window. So relying on everything to be in the global scope is still an issue. So we needed a real module system. So the module pattern with immediately invoked function expressions was enough for JavaScript for a long time. I mean, libraries like jQuery were built with this, and the whole web worked fine. But once people started moving JavaScript to the server, things were a little bit different. You couldn't just throw some script tags and throw the source in there. How do you compose something outside of a document of a web page? How do you have modules export things that can be required by other modules? And you might have an idea why I'm using these words, because CommonJS was born around 2009. And the idea here was it was standardized the concept of a module.export object, which you could completely replace and make a default export like this cheese grater. And you could compose other things with it, and you could make named exports like the super cheese grater, this tiny cheese grater. And so the way that this would work is that you could then compose these things together, and you could create whole applications this way. And when you run the program, it can recursively look up the things that you require. You can see that this requires this file, this requires this file, and then once it gets to the top, it knows that this is what it needs to run, and it can come back here and actually do things. So as you can see, this is very composable, as you can easily define what comes in and what goes out of each module. And so you can create whole applications by tying these together, especially when there's something like NPM that's a central repository of these libraries. And so you can just bring them all onto your local system and cache them. And then you have that whole node modules folder. And so let's pretend that's coming from there. And we can add diamonds to our super cheese grater and make an incredible cheese grater. And it all just works together. And the problem is, I know you're saying this is unrealistic. You can't just download a diamond. What if it takes 5 seconds to download a diamond? That's not really a problem on a server environment. Like I said, you probably have everything cached. But this time, remember, everything's coming from script tags across the internet, and you're just downloading them in those blocking requests. And so remember how that was an issue? We were waiting on things to load into the browser, and we couldn't do anything until they were loaded in. Well, that would be the same issue here. So if we bring this in, we can see that when we run the program, everything is blocked. We can't do anything. So that's why we ended up with an entirely different format in the browser called AMD, Asynchronous Module Definition. So asynchronous module definition, it's all based around this define function right here, where you can have this factory function, an IIFE inside of here that returns whatever you want to bring into other modules. And so in the other modules, you can have an array of dependencies right before your factory function here. And so whenever you bring all of them together into like a main script tag, you can then use them to, and I'm also going to have a spinner on here to show that the add diamonds, it takes 3 seconds here. We can put a spinner, and this button that we're bringing in will still work as the modules are loaded in asynchronously. So we go over here and we refresh, and you can see as I click the buttons, everything works fine as we wait for our add diamonds module to load in. This was all dependent upon a module loader. In this case, I just brought in require.js. I just downloaded it from a CDN and brought it in here. And we're using main.js, and in the index.html, we are just bringing it in and telling it to load everything it sees in main. But I just thought it was funny. If you look at require.js, you can see that this is in IIFE. This module pattern was ubiquitous in JavaScript in around 2010, whenever this was created. And so AMD worked great for browsers, and CJS worked great for servers, but they're not compatible with one another. Require and the define functions work entirely differently. And so you can't write the same script that works on the server and on the browser. And so it adds complications. And so if you want to have the same scripts that work in both environments, you have to use a different format called UMD. And it's a bit of a Frankenstein. Universal Module Definition, UMD, was brought around to tie together the worlds of CJS and AMD. So you could have one type of module that you could run in the browser or in the server, or it can even run if there is no module system whatsoever. So the way this works is very old school with an immediately invoked function expression, to which we pass a root and a factory function. We check to see if define is a function or if there's an AMD property on it, and if that's the case, we know we're in an AMD environment, so we can use a define function to bring in our dependencies. Then we check to see if it exports as an object. If that's the case, we know we're in Node.js, and we can use module.exports, and we can bring in our dependencies through the require function. And then in the browser, we can check to see if there's just things sitting on the window. That's what the root will be in that case. And then if that's the case, then we just want to bring in our cheese grater from sitting on the window object. And so as you can see, we just define our function down here, and we can return it at the bottom, and our module is going to work in any environment. So we can have this index.js and it works in a CJS environment, or we can also run our server here where we have two different versions. We have one using require.js to load in all of our dependencies, and it still works just fine. It's the exact same super cheese grater module, but we can even work with everything running off of the window object. As I said before, this would be our root in this case, where we can see the cheese grater is defined right here, and underneath all of these ons, the super cheese grater is defined right here. So this is how the UMD format worked, and this is what it would take to get scripts that would work in both the server and the browser environments until ESM came in to save the day, and we no longer had to write ugly looking functions like this to create modules that would work in every environment. So EcmaScript modules came around to save the day, and they have this really nice clean syntax where you just say whatever your default export you want it to be. You could also go down here and say it down here, and then you can also do named exports. So you can do it just like this in line, or you can do an assertion as a different name, just like this on the bottom here. And then we can bring all of these together and use the same exact script in the browser or in Node. If we just do a little check to see if we can do some DOM manipulation here, or we can just do some little console logging down here for on a server, and it works exactly the same. So over here we can check and see how we have the similar results as the asynchronous module definition, where we can load things in but still have the web page be interactive as we wait. But this, if we change our package.json over here and change it to be a type of module, then we can also run the exact same thing, and it works exactly as expected in Node. So that is why ESM are just really, really fantastic. I forgot to record this earlier, but I just wanted to show off really quickly. You can see the way AMD loads in the require.js first, and then that asynchronously loads in main and then the rest. Whereas the EcmaScript module one, we load in the index.js, and then that is responsible for loading in everything else. And you can see that that is asynchronous as well. So you might be wondering, why don't we all just use EcmaScript modules today and just make things easy for ourselves? Well, the problem is, like I said, they weren't fully supported in browsers until 2018, and Node didn't have real support for them until 2019. And so at that point, you had about 10 years of people using CJS modules to create their server-side applications, and about 8 years of people using AMD modules to create their browser applications, or, bundling it down to UMD. We'll talk more about bundling later. But so the problem is that there's so much of the web that is built on these other module systems, and you can't just break large parts of the web by saying, okay, we're not going to support this anymore. So unfortunately, you can see that like things like Jest, still only have experimental support, which is one of the biggest testing libraries. You can see that Matteo Clina and other people in Node community say that there's no chance that they will ever stop supporting CJS. It's just one of two first-class module systems in Node. And so people have to do all of this work to make things work in both environments and bundle things and do all these things in their package JSON. And this is surprisingly controversial. There's no good one system for doing this. This is Antfu, who you can usually rely on him, but people even still disagree and say that there are other ways to do this. So it's a really unfortunate place that we're at in the JavaScript community, where we can't actually all come to a place where we can say, okay, you make a module this way, it's good in every environment, everything's going to work. But that's all above my pay grade. Really quickly, we're just going to talk about how we're going to use EcmaScript modules in our application. So previously what we were doing is we were just loading all our view templates into the global scope, and then we put them into an array which we loaded into the global scope, and then we were looking through that array with our router. So we just look over here, we just expect these variables to be there, and then we expect this variable to be there so our router can then use it to look through the array. But In our new version of the app, what we're doing is the routes array just has a string, and then that string corresponds with a script that we have in our pages folder. And so what we're doing is we're then looking through the array to find that string, but then we're doing a dynamic import to then bring that component in and then returning the default export from that component. And then in our router, what we're doing now is that we then look through and the routes, and we await to then dynamically import that view template when we find it. Otherwise, we do our 404. And so the way that this works is it applies code splitting to our application so that we're only loading in the view template that we ask for. When we ask for it, we also load in a couple other things. I make this a little bit better in the next chapters, but as you can see, we load in app and then we load in home at the very end because it's the correct view template. Now we're loading in about, now we're loading in products as well as the pictures associated with it, and so we get a much better waterfall this way. If you look back here, you can see that instead of waiting for everything, we actually have an app that works before everything else loads in. We are on a fast 3G here, so it's still not the best, but it's better than it was. We will see how we're going to improve this client-side writing experience even more in the next chapter whenever we learn about the navigation API.